Okay, in this chapter, we're going to discuss rates, ratios, and proportions. And we're going to talk about how you can use units to help solve real-world problems. That's this essential question right here. Okay? Now, unit analysis. That's a vocabulary word you need to know. So unit analysis, when evaluating expressions that represent real world, you need to pay attention to the units of measurement. For instance, if P people, so you're going to use the letter P, go to a restaurant and agree to split the $50 cost of the meal. Well, think about it. If you have a $50 bill and you want to know the price per person, you basically divide 50 amongst your friends. So if you have like 5 people, 50 divided by 5 is $10 per person. So we're going to look at the 50 divided by P, and in the numerator, that's going to be the dollars. So if you have 50 over P, this is the dollars, and this is the price per person. Okay? So the units in the denominator are the people, and the units for the value of the expression are dollars per person. So you need to know how to read a problem. For instance, let's take the one down at the bottom. Sheila's participating in a multi-day bike trip. On the first day, she rode 100 miles in 8 hours. Use the expression D over T, and D is the distance traveled. Well, in this case, D happens to be 100. So that our distance, this is our D. And 8 is our T. So we're going to put 100 over 8. And what I like to do is I usually like to put the unit of measurement with it. So in this case, I'm going to put miles, so MI, and 8, I'm going to put hours. So I want to know how many miles per 1 hour. Now, it's asking us to find the average rate of travel. Now, think about this. When you find the average of something, let's say you have 3 tests. You have let's say you have an 83, a 72, and a 91. If you add all those up, you divide by 3. Well, basically you're doing the same thing here, except you're not using test. You're using miles per hour. So you want to find out by 1. So basically you take 100 divided by 8. I'm going to do a different way. If we cut both of these in half, then that gives me 50 over 4. I'm going to cut it in half again. That's going to be 25 over 2. And if I cut it in half one more time, I get 12.5 over 1. So for every hour, I'm going to travel 12.5 miles. And that right there is average rate of travel for 1 hour. Now, if you wanted to go the long way around it, you could use a calculator, or just take 100 divided by 8. Goes in 1 time. Subtract, bring down your 0. Goes in twice. That's 16. Bring down your 4. Bring down your 0. And it goes into 45 times, so 12.5 miles for every 1 hour. And that's your average rate of travel. Now, in the first problem, we found that Sheila's average was 12.5 miles per hour. Now, we're going to extend this. Now, notice, this is what she rode on the first day. But it says, that's for the first day. Then, this expression of 100 plus 12.5 times T gives the total distance she traveled after riding so many hours on the second day. So this is going to represent the first day. Now, it says evaluate. Remember, evaluate means plug this in and solve for it. So we're going to plug in 7 for 12.5. So what you'll get is 100 plus 12.5 times 7. Okay? And then that should give you your total. Now, once we fill in the blue blocks up at the top, you're going to see that we've traveled 100 miles plus 12.5 miles per 1 hour times 7 hours. Well, notice the hours cancel out because it's a denominator and numerator. So you're simply left with 7.5 times 7, which is basically this right here. And then you will add it to the 100. And what you end up getting is 100 plus 87.5, which totals to 187.5 miles. So 187.5 miles. Now, if you look at these two reflections, what are the terms? So we're looking at terms. These are vocabulary. Well, notice we have two terms. We have 100, and we need to tell us what it represents. Now, 100 represents the number of miles she rode on the first day. So 100 is the first day. Now, the 12.5 is how fast she's riding. She's going to ride, her average is 12.5 miles for every 1 hour. So you need to write that in your own words. Look at B. What is the coefficient? Remember, the coefficient is the number in front of the variable. The coefficient, what does it represent in the context of Sheila's bike trip? Well, the 12.5 represents how many miles she can ride in 1 hour, which is your average. Now, take a look at if we were only to use the units. So if you didn't use any of the numbers, notice this represents the 100. The 12.5t is represented by the miles over hours because that's miles per hour, times the h, that's the 7 hours, or that's the t actually, and where mi is the abbreviation for miles and h is the hours. Well, if you notice, if you were to solve this, this would be your 100, this is your 12.5, this is your t. Well, that didn't come out too well. But what ends up happening is the h's cancel out, and you're left with miles plus miles, which is just your miles. You're just combining like terms. Now, how can you modify the expression 100 plus 12.5 so that the units are feet? Well, if you're doing miles, you need to convert it to feet. And so you have to know how many feet are in a mile. So we'll discuss that later on. Okay, let's take a look at this one. Lizzie volunteered 20 hours. Okay, notice it doesn't say she volunteered 20 hours that week. It just says she has volunteered 20 hours. So she's already done that. Well, that right there is how many hours she's already put in. Now, the hours per week, notice she plans on volunteering 5 hours per week. Well, here's your hours, here's your per week. So that is your 5. So that's your 5 right there. Now, we need to multiply it by something. All right? So that basically would be your week. So we're going to put that as, that's your week. I'm going to just put WE. So when these two cancel out, you're left with just hours plus hours, which equals hours. And we're going to go ahead and skip the rest of this, but we'll come back to it later on. Now, if you'll take a look at these 3 questions, these are just extensions on how you can take the original statement and expand. In other words, how many hours will Lizzie have volunteered at the library at the end of 10 weeks? You can say she volunteered 10 weeks already, and now she's going to volunteer for 3 hours a week, beginning in week 1, and then rewrite the algebraic expression. So again, there's some extension here. And then finally, how many hours will Lizzie have volunteered at the library and the animal shelter combined at the end of 20 weeks? So these are some extensions we can work on. Now, you need to be on the lookout for certain things like this. Henry drives in town at a rate of 25 miles per hour. Okay, so that's 25 miles per hour. Okay, it takes him 15 minutes to go to the library from his house. The algebraic expression R times T, so that's your rate times the time it takes for you to get to home, is going to give you the average rate. Okay, and T is the travel time. So now, if you look at this, so this is 15 minutes. Well, if you look at what we've done earlier, normally what we would do is we would cancel these two out because hours and hours would cancel out. But if you notice, this is hours and minutes. So I can't multiply those two yet. I have got to convert this right here to hours. So think about a clock. Okay? If you think about a clock, 15 minutes is a quarter of an hour. So if you have 1 hour right here, so basically in this time, remember 15 minutes is, if you look at a clock, 15 minutes, that's actually 1/4 of an hour. So this would have to be 1/4 of an hour. Then you can multiply it. So when you do this, 1/4 of 25 miles, so that means if you look at a clock, that means this would be 25 miles. Half of it would be 1250, and half of that would be 6.25. And that's how far he has traveled. So remember, there's always more than one way to solve a problem, but you have to be consistent. So if this is hours, this has to be hours in order for it to eliminate. So I converted the 15 minutes. Now again, this is a little sloppy, but if I cut it like this, the whole thing represents 25 miles. Half of this would represent 12.5. And then when I cut it in half again, this half of 12.5 is 6.25 miles. And that's how far Henry lives from the library. Alright, so let's take a look at your homework. Now in this first one, we have 4 dozen every 18 minutes, and we want to find the average rate. Now, is that the average rate of dozen of donuts per minute? Or is that the average rate of donuts per minute? Now think about that. If it's donuts per minute, then 4 times 12, because there's 12 in a dozen, that would be 48 donuts. So let's go ahead and go with that. So if I have 48 donuts, so I'm going to put donuts up here, and 18 minutes, well, if I were to divide 48 divided by 18, that would give me, now it's to the nearest hundredth, 6, which that rounds that up to a 7. So let me go ahead and update that and put a 7 right there. So 2.67 donuts per minute. So I'm going to put donuts per 1 minute, and that's the average rate to make a donut. Now, number 3 is interesting because it's kind of giving you a proportion. Now, if you look at this, the birth rate in Namibia is 35 babies for every 1,000 people. Well, if I have 35 babies for every 1,000 people. In 2001, the country had a population of about 1,800,000. Well, so my population now is 1,800,000. I want to know how many babies there were. Well, in this case, it's a proportion. So what you have to do is you're going to solve, let's say this is your variable. So let's put this as B for babies. Well, remember, in order to get rid of the denominator, you multiply. Now we could cross multiply, and what you end up getting is 1,000 PB, that's the population, and this is babies, is equal to 35 babies and times 100 or 1,800,000 population. Now notice this is your population, that's P. So when you multiply this, what you end up getting, you're trying to solve for the number of babies. So when we divide by 1,000, notice the P's are going to cancel out. Now this is a P, so that cancels out, and you're left with just the B for babies. So let's try that with a calculator. Now, when I do all that mathematics, this 1,000 cancels out, and I'm left with just B for babies. And when I multiply 35 times 1,800,000 and then divide by 1,000, then I end up getting 63,000 babies. Go ahead and remember to put your words with it. Okay? Now, we're going to look at number 5 here. Okay? The Hendersons are driving cross country from Boston to Los Angeles. The first day they drove 300 miles. So, now notice that doesn't say 300 miles per day or 300 miles per hour. They just drove 300 miles. Now, if you look at question 5, we need to write an algebraic expression to represent the length of the trip. So, you know what? on the first day, that's day number 1, they drove 300 miles. We're going to add that to however fast they drove. Now it says they plan on driving at an average speed of 60 miles per hour. Well, there's your 60 miles per 1 hour. So that's the equation you have to work with. Now notice, they're going to put t as time. So instead of 300 plus 60 miles, we can actually rewrite that as 300 plus 60t, and t being the time in hours. So we're going to put that, and if you notice, that one, it's not A because it's 60t, it's not B because that's minus, it's not D, that's minus, so it has to be C in that case. And that is how I want you to justify your work. Look at number 7. Now, if the Hendersons drive for 9 hours per day, how many miles will they travel in 1 day? Well, think about it. If you have 300 miles and they're going to travel 60 miles per hour, and they're going to drive 9 hours, well, the hours cross reduce. You get 9 times 60, so you end up getting 300 plus, remember 9 times 0 is 0, 9 times 6 is 54, so when you add those together you get 840 miles. So altogether they would have driven 840 miles, but look at what the question's asking. How many miles will they travel in 1 day? Well, they've already traveled 300 miles, so we're not looking for that. They're not looking for how many hours they're driving. 9t represents hours, not miles. They didn't go 60 miles. That's how fast they're driving. Well, if you notice, they went in 9 hours. They drove 540 miles that 1 day, and so D is the answer. Now it's your turn to do all the evens.